Hello and welcome back. Today I'll be going over matrices, how to add them, subtract them, and multiply them. Now let's go over exactly what matrices are. Matrices are an arrangement of numbers in a rectangular shape, in rows and columns. We use matrices to help represent equations or to represent data for computer science. We represent a matrix's dimensions by its rows and columns. For example, let's look at this matrix. We can see here that it has 2 rows and 2 columns. So we refer to this matrix as a 2 by 2 matrix. Now that we understand what matrices are, let's begin with learning how to add and subtract them. In order to add and subtract with another matrix, they have to have the same dimensions, or size. So both matrices need to have the same number of rows and same number of columns. If we look at the first problem, we can see that this matrix has 2 columns and 3 rows, but the second matrix has 4 columns and 2 rows, so we can't add or subtract these matrices. The second example, however, both matrices have 2 rows and 3 columns, so we can add or subtract them. Let's do that. When you add matrices together, you add the numbers in the corresponding spots of each matrix. For our example problem, we can see that in the first row of the first column of each matrix, we have the numbers 8 and 9 respectively, so we can add them together to get 17. For our final matrix being the answer, it's also going to have a dimension of 2 by 3. So, we're going to put the 17 in the first column of the first row of the final matrix. We do this for the rest of the numbers. The top middle of our two matrices here add up to 7, and we put that in the top middle of our final matrix. Pause the video and try to complete the rest of the matrix on your own. This is what your final matrix should look like. Let's try to do an example of subtracting a matrix. We simply do what we did for the adding, but this time we subtract the numbers. These two numbers give us 3 when we subtract them, so we put it in the corresponding spot. Try to do this one by yourself by pausing the video. This is what your answer should look like. Now that we understand the basics of adding and subtracting matrices, let's go on to something a bit harder, multiplying them. Now how exactly do you multiply matrices? Some people might think that we do exactly what we did for addition and subtraction, but sadly we use different rules here. When we multiply a matrix by a single number, called a scalar, it's actually quite easy. We just multiply each element in the matrix by the scalar. However, if we want to multiply two matrices together, it gets a bit more confusing. If we want to multiply two matrices, A and B, the number of columns in matrix A have to be the same as the number of rows in matrix B. Let's try to visualize this. We have here matrix A and B, and we want to find out what A times B is, which is multiplying matrix A and B. Well, can we even multiply the matrices? Let's write out the dimensions. The first matrix here has a dimension of 1 by 3, and the second one has a dimension of 2 by 2. The columns of the first matrix are not the same as the rows of the second, as 3 is not equal to 2. However, let's look at our second example. Firstly, let's list out the dimensions. As we can see, the columns of the first matrix are the same as the rows of the second, so we can indeed multiply the matrices together. Now, what is our product going to look like? See how we took into account the columns of the first matrix and the rows of the second? Well, the product matrix is going to have the amount of rows from the first matrix and the columns of the second matrix. The matrix AB, our answer, is going to have 1 row and 2 columns. Now the multiplying part. When you multiply matrices together, we do what's called dot product multiplication, which is taking the dot product between a row and a column. To take the dot product of a row and a column, let's look at this visual. First, let's work with the first row of the first matrix and the first column of the second matrix. We go to both of our matrices and we look at the first number of the first row and the first number of the first column. We then want to multiply those numbers together. We then want to move in a much weirder way. For our first matrix, we still look at our first row, but we go to our second column. But for our second matrix, we want to go to our first column, but our second row, and we want to multiply those two numbers together. Then, we want to add those two products together, and we get our first row, first column answer for our answer matrix. If you're confused on this whole multiplying part, think of the multiplying pattern as a slide rod on a train wheel. This helps to find which number should be multiplied in the matrix. Let's do this for the rest of the row-column combinations. We're still using our first row here, since we don't have any other rows in the first matrix, But now we want to look at the second column on the other matrix. Let's extend our train rod a bit and do the same thing. Here, we do 2 times 3 and 7 times 2. We then add those numbers up together, and we get the value for the matrix in the second column first row spot. There's our answer. Let's try apply this into a new problem. Here, we have a 1 by 3 matrix multiplied by a 3 by 1 matrix. We can see that the columns of the first matrix match the rows of the second matrix, and we know that our final answer is going to be a matrix of 1 row and 1 column. A matrix of this sort is known as a vector. In this case, we simply multiply all the numbers together and add that up to get our one single value. I do this on your own before I reveal the answer. This should be the answer that you've gotten. You now know how to multiply, subtract, and add matrices. Thank you for watching, and if you have any questions, leave them down in the comments below.